Done now? Okay. All right. So if you could all just look up here for me. Okay. So first of all, this is the network called the global routing prefix, right? It's the global routing prefix. And this is given to me by, right, by the ISP. How many bits are in an IPv6 address? 128. Now, how many make up the actual network piece of it? The first 64, right? So the first 48 is the global routing prefix. Remember, what we do is we do the subnetting in what hextet? The fourth hextet, right? So that might look like, again, right now it just is zeros, right? So that's still a 48. So in that example that we did today, whenever you need to subnet, unless the ISP tells you differently, which we're going to talk about that next, you subnet in the fourth hextet. And this is where all your subnetting has to stop. You don't go beyond the 64th bit. Unless, again, the ISP has some weird reason to have you, okay? How you subnet this will be up to you as the network administrator or whatever the process is that your company has set. So in that example, I don't remember it, what the first one was, but I think it was like the states use the first nibble. So maybe you have like Arizona, Colorado, New Mexico, right? Now, if I just use the first nibble, so let's just bit this out because this seems to be, so this is how many total bits right here? 16. And the reason is because these get bit out, right? This really represents 4 bits. And this represents 4 bits. And this represents 4 bits. And this represents 4 bits, right? So here is 16. So how do I write C? It's 12. Okay, 12. D is 13. 0, 1. Okay, so now what are we at? How many bits? We're at 32, and then A is 10, B is 11, and then A, how many are we at? So that's how we get the 48, okay? So now again, let's just use our Arizona, Colorado, New Mexico example. Okay. Now we know that from studying IPv4, every network has to be unique, right? If I have the student department and I have an enrollment department, you know, one might be on one VLAN 10 and enrollment might be on VLAN 20. They have to have their own networks. Yes? Do we agree with that? Okay, the exact same is true with IPv6. Every network still has to have a unique network. And we use VLSM and IPv4 to make things unique based on the number of what that each network needs. Hosts, the number of hosts, right? Now with IPv6, do I care at all about the number of hosts? I really don't. Okay, so that's why we just can use this entire 4th hextet. Okay, so again, I'm just going to assign Arizona number 1, Colorado number 2, and New Mexico number 3. Just because I can. Just because I can, right? Jocelyn used A, B, and C. That's totally fine too. okay? And I'm going to use the first nibble of the 4th hextet. All right, so let's do Arizona. Okay, so I've gotten this far. Now I'm going to use the first nibble of the 4th hextet, and the rest are all just zeros. Okay, so now I'm going to keep doing some subnetting, okay? But I want to make sure that Arizona has its own unique network portion, even though I'm going to subdivide that again. All right, so now we've got how many bits right here? Plus 16 is 32, plus 48, and then 49, 50, 51, 52. So right now, my network portion actually stops right here. Now this is still part of my subnet ID, but I'm not done subnetting yet. So really what this is a 52. Does everybody understand why? Yeah. Okay. Now in Arizona, I want to have 3 divisions. I don't know, we'll just break it up by college, right? Let's just say we have GCC, we have MCC, and then I have Phoenix College. Okay. Now again, I want them to also be unique. They can't, I have to separate them and make them unique somehow. Okay. So let's make this one A, let's make this one B, and let's make this one C. Now I'm going to just give you an example here, okay? Now to do this, I want to use the 3rd nibble. I'm going to use the 3rd nibble to create this uniqueness. Okay, so I'm going to use this one. I've already used this one to represent the states. Now I'm going to use the 3rd one to represent colleges. Are we good with that? Okay, so now this is going to be, again, Arizona, but I'm going to do GCC. Okay, now everyone understands the network portion stays the same, right? Okay, so this is going to stay the same. This will stay the same. And this will stay the same. And because I'm in Arizona, I want all the Arizona colleges to be identified by that first nibble. So that's going to stay the same. But we're doing GCC, and I'm using the 3rd nibble. So this one's going to stay 0. Now, I could have used the 2nd nibble. I just opted not to. Just because I can, not because I had any reason, right? Just because I can. Okay, so if GCC is A and I'm using the 3rd nibble, how do I write A? 1, 0, 1, 0. Okay. Now, here is where it's stopping for the state. So now how many bits am I at for the whole network portion? I'm at 60. So now I'm at 60. Now if I were going to do MCC, right, it would be 2001 CD01 ABAA B, right? It would be 1, 0, and this would be a B. Okay, so let's do, now we're still in Arizona, but we're doing MCC. So again, this part all stays the same, right? And this is the part that represents Arizona. So that's going to stay the same because we're still in Arizona. Okay, we're not doing anything with the second nibble, but MCC is B, which is 11, right? And we're still a 60. Does everybody see that? Okay, next. Yep, I could have changed it on the second. And maybe if I had 4 different ways that I needed to subdivide this, I would have. Okay, so I want to subdivide this one more time because I want to get to the 64. So I'm going to subdivide GCC into students, the enrollment center, and the IT department. I have the 4th nibble left, so I'm going to use the 4th nibble. Okay, so again, just looking at MCC, right, or GCC, so students, I'm going to make this 1, enrollment 2, IT 3. Okay, so now, again, I would be subdividing GCCs. So now that's going to be 1, 0, A. What would the 4th nibble be? 1. Okay, so now I'm doing the students. So I'll write it again separate, right? So it'd be Arizona, GCC, the students. Okay, now this stays the same because it's the network. Just like IPv4, the network stays the same. All right, so this is all the network. Okay, am I still in Arizona? Yes. Right? Am I still part of GCC? Yes. And now I want to designate the student network. Now I'm at the 64th bit, so I'm at a /64. Okay? Now, we can count the zeros. I could have said 0, 0, 0, 0, and then that's a 64. Because if I'm counting those bits as part of the network, the zeros, I would have made it a 64. I personally always start with 1. I never use the 0 because I find it confuses people. Okay, it doesn't confuse me because I know to count up the bits. But I find it just confuses people if I don't use 1, 2, 3, ABC, something like that. Okay, all we're doing is counting bits. Just like IPv4, you got a /22. How many network bits do you have? Really? A /22. How many network bits do you have? 22. It's not a trick question. If it's a /22, how many network bits do you have? How many host bits? 10. If you have a /16, how many network bits do you have? How many host bits do you have? All right, it's not a trick question, guys. I'm like, uh-oh, I'm like nervous. What if you have a /9? How many network bits do you have? How many host bits do you have? If you have a /9, how many network bits do you have? Everybody, how many network bits do you have if you have a /9? How many host bits do you have? Subtract 9 from 32. Just do the math. 10 minus 32 is 22 plus 1 is 23. I don't know what's going on. Do we all have to go back to algebra? I'm like, what is happening? Okay, so we're going to do, come on, what's happening? Okay, can you refresh your screen? Man, why doesn't this erase right? Okay, so let's do this one. It's called Brain Teaser IPv6. Determine the IPv6 network using the prefix length, okay? This one, has everyone got it? Okay. So let's work through these together based on what we just learned. Okay. So remember, we're just counting bits, right? So I know that the book teaches us that, oh, it's always going to be a /64. It's not really always a /64. Okay, so let's look at this. And we'll do this, let's do this together. Now what you have might be a little different than mine because it just randomly selects questions, okay? So if we just look at this, given the IPv6 address and the prefix link, so notice here they're giving us a 36. They're not giving us a 48. They're not giving us a 64. They're simply telling us that the first 36 bits are the network, okay? So this is how many bits? 16. So we know that this part is part of our network, right? Because we've got to get up to 36. And then another, right? So 32. So that gives us 2E, 4B. So 36 is going to fall in what hextet? It's going to fall in the third. So let's bit out the third hextet. Okay, we're going to bit it out. So how do I bit out 8? Yep, 1, 0, 0, 0, and then another 8. Yep, 1, 0, 0, 0, and 3. Yep, and then A. Yeah, and we've actually even gone farther than we have to. So if this is 32, then we just need to count to 36 because they told us there's 36 network bits. So 33, 34, 35, 36. So the rest of these are what kind of bits? They're hosts. So what is this value? 1, 0, 0, 0. 8. So the network is actually 8. Okay, and then the rest would all just be zeroed out. So let me just look and see if I can tell how they've entered the, let's see, does it tell us how to enter the answers? Let's see. Answer would be written as ABCD 3400 : Okay, yeah, so they just want us to do zero out all the hosts. So that's how we would write it. So that's the network piece, and it just wants us to zero out all the hosts. Okay? So we're just counting bits. It's stuff we've been doing all along. So let's do another one together. So this one's a 40. Okay, so this one is a 40. So what hextet do I need to think about? The third again, right? Because 16, 32, this takes me to 48. So if I do E, so let's do the E, that's going to be 14. Oh no, E is. Yeah, I was doing the opposite. Good catch, right? And then B, that's 1011. And then 2. And then 6. Okay, so I have 16, 32, 33, 34, 35, 36, 37, 38, 39, 40. So there's where my network stops. So I've got 2001, 1F, 5F. Okay, then what is this one? E. And this one, B. And then what do I do with these host bits? I just zero them out. So that's the network. Slash, it doesn't say to put the /40 in, but that's what it is. Okay? So go ahead and do yours. If you need help on one, call me over. When you're done, will you just pop your hand up? Or if you get stuck, again, just call me over. I'd be happy to take a look at it. You're finished. Okay, perfect. And you got them right? Good. Excellent.
After doing this, I see where I messed up on the type.
Yeah, yeah. Maybe we should have done that one first. Yeah, you just have to count those bits. When you're done with that, go ahead and work on the compress and decompress. Does everybody remember the rules for IPv6 compression and decompression? So it's important that you read these directions really carefully because it's wanting you to practice different things when it comes to IPv6. So look at the following IPv6 and use all compression rules. And I think this one might only be asking for full compression. I can't remember. Let me show you how I do this so that I don't make mistakes. I actually copy and paste the whole thing. Jocelyn, look. So this wants you to use full compression, which means it wants you to omit the leading zeros and use double colons. So what I do is I put the whole address in here, and then I look at one hextet at a time. So 2001, do I need to do anything? Nope. 8000, do I need to do anything? What about 000D? What do I do? Do what? Right, so I'm going to get rid of those. What about 0200? Just delete the first one, 0200. Yep, just delete the first one, A030, C0C6 with 0000. Double colon, double colon. Okay, so I just copy and paste the whole thing. That way I'm much less likely to make a mistake. So go ahead and do these. If you, I know a couple of you have already been working on this. That's totally fine. Just finish it up. Or if you had a mistake and you need to do it again. Oh, and then there's some decompression questions in there where you're decompressing the address. All done? Okay. So it is 3:56. Let's take a break. Let's come back at 4:05. And then we're going to finish up talking about IPv6 and Slack and DHCPv6. Okay, so which configuration is it? Umberto, what did you say? Because I think it's, no, it doesn't generate the GUA. It doesn't generate it. The interface ID. Okay, if the auto flag is on, what is the network using to get addresses? Which one of these? If the A is on, what are we using? Huh? You're using Slack. Okay, again, don't make this harder than it is. If auto configuration is on, the IPv6 addresses are being auto-generated using either the EUI64 process or random generation. And that's regardless of whether I'm using Slack or Slack plus DHCP. Okay, so with Slack, is the A flag on or off? Yep, it's on, right? It's on. Now, what about the O flag? Is it on or off? I'm sorry, what was it? Off, right? It's off. And what about the M flag? It's off. Okay, now if we're using stateless DHCP, is the A flag on or off? It's on. And why would it be on? Yep, because we're using Slack to generate the IPv6 address, the interface ID specifically, right? Okay. So in this scenario and in Slack, remember the router sends what kind of an advertisement? It sends a router advertisement. And inside the router advertisement, what does it have? It'll have the flag. And what else, Adiel? Yeah, it's going to have the prefix. So it'll have like 2001, bad CAD, right? And then it'll have whatever the subnet ID is. So let's say it's 1064. Okay, so now the device, right, it receives the flag. And it's like, oh, okay, I've got an RA flag saying that the auto configuration is on, right? So the A equals 1. So it's like, cool, I'm just going to self-generate using the EUI64 process. Now, even if the A flag is on and it's Slack, does the EUI64 process always get used? Why not, Umberto? Okay, so if you're not using the EUI64 process, what's happening? Just randomly generating. The computer just spits out a bunch of numbers. Okay, so now that it's been randomly generated or it's used the EUI64 process, what does the host do next to make sure that the address is unique? It says dad, right? It does a duplicate address detection. It sends it out a frame or a message that says, is anybody else using this? As long as it doesn't get a response, it knows that it's unique. Okay, so back to stateless. Now, what about the O flag in stateless DHCPv6? Is the O flag on or off? Right, this one's on because we're going to use Slack to figure out the IPv6 address, but I want you to get other information from the DHCP server. I want you to get other information from the DH. So what might that be? That might be a DNS server. It could be FTP server. Who knows what they've got over there, okay? All right, and then what about the M flag for stateless DHCP? Yeah, it's off because This M, remember, that stands for managing the IP address, right? So that would be a DHCP server. Okay, just plain old-fashioned stateful DHCP v6. A, that one's off because we're not even entertaining Slack. Now what about the other flag? It's off. And the M flag, on. Right, because the DHCP server is just gonna do everything. It's gonna manage everything. Okay, does that all make sense? Okay. And again, remember those all go in here. So if I said the A flag is on and the M flag is off and the O flag is on, you should be able to say, oh, well, that's stateless DHCP. Okay. All right. Do we need to go over the UI64 process? Raise your hand for a yes. Yes. No? Okay. Wait a second.
I need to check my grade on how I did on that.
I haven't graded it.
Okay.
Do you know how to do the EUI64 process? Yes. Do you know, are you, okay, on a scale of 1 to 3, are you a 1, 2, or 3, with 3 being the best?
I can have a 3.
1, 2, or 3? 1, 2, or 3? 1, 2, or 3? All right, we're going to do it. We'll just review it kind of quick. It's not too bad. You just have to, again, break it down nice and slow, right? Just don't rush through it. So this 2001 CD, a bad 001, what is this? It's the network, which is made up of this part, which is the what? The global routing prefix, and this is the subnet ID, the two of them together we call the network, and that's how we get to 64. Okay, so this information will be delivered to my computer in the form of a what? A router advertisement, exactly right. This will be sent from the router, right? It's going to be a router advertisement that gets sent to the PC. The PC is going to de-encapsulate the advertisement, and inside there, it's going to see A flag equals 1. It's going to see the O flag equals off. It's going to see the M flag equals off. And it's going to see the 2001 CD00 ABADE0001. And then the host is going to say to itself, yay, I get to generate my own, what? My own IP address, my own interface ID. So it's going to look at its own MAC address, and I'm just going to do a nice easy one here. Okay, so it's got to do what to this MAC address to do the EUI64 process? It's got to split it in half. So that's what we would put right here. We're just showing, this is just to visualize it, right? This is just so we can visualize it easier. That's all this does. What goes in the middle? Yep. F, 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 E. Okay. Now again, this is just to make this, to visualize it. That's the only reason this is like this. B, 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 F, 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 E, B. Oh, I did too many B's, not enough A's. A, A, okay. B, A, A. Again, it's just to visualize it. Now, what do I have? Why is this highlighted like this? Right, we're going to convert it to binary, and then what do we do to it, Wyatt? Flip the 7th bit. So A, right, this is just going to stay A. But this one, we want to do a little bit to it. So if this is how many bits? The first nibble is how many bits? So then 5, 6, 7, this is the one that I flip. So now it's going to look like this, right? Oops, 0. So it's going to be A what? It's going to be A8, right? Yes? Okay. So then we just combine everything. So now the host is going to take the network that was given to it, right? The network was given to it. So it's going to take that. And now it's just going to plug this in. So it's going to plug in A8, A, B, yep, F, FE, BB, AA, slash 64. So now we have how many total bits? 128, right? 128. So that's the process. Now, if we have EUI 64 turned off, the host just grabs a bunch of hexadecimal values, churns them up, and spits them out. That's all. And here, do we have EUI turned off or on? Off, right? You can tell by going to the IP config, and if you look at the command prompt and you do an IP config all, and we can, let's see, auto configuration. I can look right here, and I don't see any FFFFE in there, so I know that it's turned off. Good with that? Good, okay. Yeah, most of the stuff, it's not that it's hard, it's just that you have to be methodical about it, because if you miss a step, A, it can confuse you, and B, the answer could end up being wrong. Let's see, so we're just going to review this. Oh, that was left on. Okay. So some of the important things in this module is you've got to know the different ways that hosts can get their addresses. You have to understand the flags and what the flags mean, because that's how the host knows, right? And then also, let's take a look at that assignment that we did last week for DHCP, because we want to know what the different messages are, right? So let's look at this assignment. We'll even review DHCP, just regular version 4. Let's do DHCP v6 first. Okay, so first of all, you come in, you turn on your computers, right? And they want to start gossiping right away. So what message is the client going to send to the server? Let's do 6 first. What is it? A solicitation, right? So it's going to do an RS, or a solicitation. So think of it kind of like buying, right? I want to buy an address. I'm out there shopping. I'm out there shopping for an address. Now, how is this sent? What kind of a message? Yeah, this is a multicast. And can you tell me what the address is? F. Right, it's actually a 2. A 2, okay? Now, when we go through our discussion today, did you hear that? Was it a weird noise? We're going to talk a little bit about this. Okay, so it sends the message, the server, really the router, right, receives it, and it's going to respond with a what? An advertisement, router advertisement. right? And this is where those flags come in, right? Okay, and how do we send that message? Multicast. FF021. So this is the all routers and this is the all nodes, which is just another way of saying all computers, all hosts. Okay, so the client receives this message, right? And then what does it do? What does the client do next? It does what? A neighbor solicitation. I don't think so. That's part of. It does not do a DAD. It's not a router. Okay. The client asks for an address. The router responds with an address or what it's supposed to do. And now what does the client do? What is the DHCP v6 message that it sends back? I heard it. I think it does a request, right? It does a DHCP v6 request. Right, it says, is it a request? Yeah, it's a request. It says, I'd like to, it gets the information, and it says, oh, I would like to go ahead and request that address. So it responds to the server, and then the server does what? It will, is it an acknowledge, do they call it an acknowledgement? I think they call it a reply. This is called a DHCP v6 reply. Now, that's sent within an advertisement, within a router advertisement. Okay, now what was this message type? No. Still multicast. FF02::2. What's this one? Say it's still a multicast. I think this one's still a multicast. FF02::. We might need to check that one. I think so. You know why? Because this one, this host does not get its address. It doesn't, even if it's self-generated, until it receives the reply giving it the go. That's like the final, okay, good, we're ready to go. Okay? So I have this in a slide. We'll double check ourselves and make sure we got this right. I think this is actually called an info request. I don't think they call it just a request. I think it's an info request. I was in the reading. Yeah, an info request. Let's just review DHCP v4. So what's the DHCP message? Right? It's like, I want to do a discover. I want to discover an address. How do we send it? Broadcast, which is a 255. Okay, and then the server receives it and it does it's going to send a message back. What's the message back? An offer. I have an ad, so you want to discover something. I have one to offer you. What's the message type? What address does it use? Huh? Nope. Yes. It actually uses a unicast 000. DHCP, so the client receives the offer and the client responds with a what? A request. It says that offer looks good. I'd like to go ahead and request that address. What is the type? It is a broadcast. Okay, the server receives it and it does a what? It does an acknowledgement. what kind of message is being sent. Unicast. Now I believe, again, it's still going to the 000 because this device cannot get the address until it actually receives the acknowledgement. Once it gets the acknowledgement, that's the first time it actually has an address other than 0000. Okay? Got it? Good. Okay, so we've actually already been talking about all these ways for IPv6. We can assign them statically, or what's the other way? Dynamically. And if we do dynamic, what are the 3 different ways? What are the 3 dynamic ways of getting an IPv6 address? What is it? Stateful. Okay, so just plain old-fashioned DHCP. Okay. Slack. Well, that's stateful DHCP. So stateful DHCP is just plain old DHCP with a server. So what's the other kind? Stateless DHCP, which means we're using Slack, which is stateless. So whenever you see the word stateless with IPv6, that means Slack. So if you see stateless DHCP, that means we're using Slack plus DHCP. Okay? All right, so we've got stateless, also called Slack. We've got Slack plus DHCP, and then we have just a plain old-fashioned DHCP server. Okay, so it's the flags in the router advertisement messages that tell the host how they're going to be getting their address, whether they have to do the work themselves or whether a server is going to be doing it. Okay, we've got the A, the M, and the O. So we've already done a nice job of reviewing all of that. Okay, and we just did this. Oh, so we'll check ourselves, right? So the DHCP does the solicit. This is the client. The client says, I need to buy an address. Okay. Now, do you see how this says all DHCP servers? That's actually a little different than the all servers, okay, or the all routers message. You know, in the book, it really just talks about the all routers, FF02::2, and the all nodes. But the truth is, there's all kinds of multicast addresses, okay? So there's a DHCP server's address, which I believe is FF02::6, if I'm not mistaken. Okay, so again, the book, it doesn't give us the full story, right? It's kind of giving us the abridged, the abbreviated version. So the server is going to respond with an advertisement, right? Now the client, so here's that little breakdown where it was an information request versus a regular request. With stateless DHCP, it's called an information request, right? So if I'm running Slack, requesting only the parameters such as DNS, with the DHCP v6, so just straight up a server, it's just called a request. I hope that on the CCNA we don't have to break it down that, you know, into that minuscule of a detail, but anything's possible. Okay. And then finally, the server will send a reply. So we got it mostly right. Again, this is just that little discrepancy of what you have to know the difference of. Stateless meaning there's no server. It's just stateless. And then here was just a review of our IPv4, which again we just went through. Let's see. So what are the 3 flags? The first one, and the next one, and an M, right? We have an A, we have an O, or an M in this case, and an O. So if we break it down, right, we know we're using Slack. And let's see, if it's off, we're not using Slack. okay? What do our devices, what do our routers use? What's the default? Yeah, the default is A, it's Slack. All of our routers are automatically defaulting to Slack. So if you wanted to use them to distribute IP addresses, IPv6 addresses, it will do it automatically. You have to actually go control the flags in order to set up a DHCP server. Okay, so this is an important distinction. Our routers can perform Slack, okay? You can also tell the router that you want it to function as a server. Now that's different than Slack. It is taking a little bit of the CPU, a little bit of the hard drive, a little bit of the RAM, setting it aside in the router, and now the router will continue to function as a router, and it will function as a server. It has that capability, okay? That's different than Slack if you're telling it that it's going to be a server. Now, I could also just plug a physical server into my network, okay? So we've got the M flag, right? A DH. So if your M flag is on, that means that you've got a server that's managing the IP addresses. Okay, it's managing the IP addresses. And O, again, that means I probably have a server on my network and it's maintaining other information, but it's not managing the what? Right, it's not managing the IP addresses. It's not managing the IP addresses. So if the address comes from, yeah. So if the O is on, it's got a job to do, but it is not giving out the IP addresses, okay? But it does have a job. The server's doing something. It's just not doing addresses. Okay, it's just not doing addresses. Let's see. So this is just the different way. So again, if my A flag is on and everything else is off, what am I using? What is it? Auto configuration or Slack. Now here my A flag is on, my O flag is on, and my M flag is off. What am I using? Right, I'm using Slack plus DHCP. Now my A flag is off and my M flag is on. Stateful, right? There's a server and it's managing everything. So let's see here. What is the question? AMO, flags are always referencing the DHCP server from the perspective of the router. Is this a question? Oh, so what can we determine by looking at this output? So it's not using the EUI because I can tell that there's no FFFE in there, right? But I think we can tell something else. What else can you tell? What? There is a link local on it, yes. Which that would make sense because every device has to do what? Huh? It has to generate its link local address. So what else can you tell by looking at this output? What? It is randomized, yes. This is a question straight off the CCNA. It what? Oh, that just means there's more values afterwards. Evaluate it line by line. That doesn't mean anything to us. We don't care about that. What I'm looking for, you can tell by looking at that output, the 21 doesn't mean anything to us.
There is no server
How do you know that?
because there is no the computer does not get the IP address from any server.
Exactly. IPv6 address, is there one? IPv4 address, is there one? There is, but what kind of address is it? And why would I get an APIP address?
Because there is no DSCP, the computer does not receive the IP address from DSCP.
Right. You can tell there's no DHCP server connected to this host. It does not have an IPv6 address. It has self-generated its own link local address. It has self-generated its own APIPA, which is an IPv4 link local address. And it does that because it wants to do what? It wants to gossip. It wants to talk. These devices always want to be able to talk. So it self-generates its own address. If you see a 169, that means there's no DHCP server. It can't connect to one, whatever the reason is, whether there's an error, whether there isn't one, who knows. So when you look at this, and oh yeah, there's no default gateway because it's not connected to a server. So when you see something like this, you should be, well, that's weird. There's no IPv6 address. There's no IPv4 address. It looks like there's no server. Okay, again, that question comes right off the Cisco, the CCNA exam. So that's a question you need to know how to answer. The IPv6 is automatically created. Right, the interface did not create a global unique address. Right, there's a 169.